be taking notes on data regression. So data regression is just the relationship between data points. And by the end of class today, you will be able to first analyze data and select an appropriate model. So our models are linear, quadratic, and exponential. You will be able to write a function based on that model, and you will be able to make a prediction based on the equation we got from the model. So there are 3 steps for data regression. Step 1 is to enter the data points. So let's do that together now. So let's do our first example, a linear regression. And we know that the graph for a linear regression will look like our linear parent function. So it'll look like a straight line. All right, so first we are going to use Desmos to enter our data points. So I'm going to go to Google. Where's Google? Why it didn't pop up? Here we go. And I'm going to go to a new tab. So on my new tab, I'm going to type in Desmos calculator. Calculator. There we go. And we're just going to click on the first one. All right, so I'm going to split my screen so that I can see my notes and my Desmos at the same time. So here's my notes. I'm going to put my notes on one side, and Desmos, where is it? Here it is. No, that's not Desmos. Where's Desmos? There it is. Desmos we're going to put on the other side. So all I did right now was just split my screen. I have my notes on one side and Desmos on the other. So to enter a data table, we're going to click this button, and then we're going to choose table. All right, so for our x values, we're going to put all our x values in. So 1, 2, 3, 4, and you see it's automatically put my numbers in there for me, all the way to 5. And then for y, we're going to put in our y values, 6, 9, 12, not 18, 12, 15, and then 18. All right, so now I'm going to make this full screen so we can see it. We have to look at our data points. So that is it for step 1. We enter our data points, and now I'm going to zoom out a little bit so we can see all of their points. And we have to look at it and say, this is a linear regression because it is a straight line. So that is step 1. So let's go back to our notes. Now we need to find the equation. So to find the equation, first we have to look at what is our equation model. It is y is equal to mx plus b. So we're going to go to Desmos, and I'm going to make this split screen again. And on the second row, I'm going to put y1 because in our graph we have y1. And instead of equal, I'm going to put the tilde sign. So you're going to hold shift and press tilde. It's the button next to 1. y1 tilde m x1 plus b. And you see it matches the equation I have here. The only difference is I have y1 and x1. And to put the 1 at the bottom like that, you'll just type the 1 after the y and after the x. All right, so if I scroll down at the bottom, you see here, they give me my values for m and b right here. So I'm going to go back to my notes. And for m, we have 3. So I'm going to put 3. And for b, we also have 3. So when I rewrite my equation, it should be f of x. So f of x is the same as saying y. F of x is equal to 3. Oops, it's not writing. 3x plus 3. All right, so that is how you find your equation. Our last step is to make a prediction. So to do that, we are going to, this equation we see here, we are going to type this equation here into the third box. So we're going to click F parentheses of X, close parentheses, is equal to 3X plus 3. And when you do that, your line should go straight through your data points. That's how you know you have the correct line. Then we're going to look for what is F parentheses of 7. What is F of 7? We're looking for what is the value of F when X is equal to 7? Or what is the value of Y? Because remember, F of X is the same as saying Y. What is Y when X is equal to 7? Well, when X is 7, you see right here, Y is equal to 24. So we're going to predict that based on this table, if I were to predict at 7, my Y value or my F of X will be equal to 24. So I'm going to type that. Oops. Pretty simple, right? All right, I wrote 241, just 24. All right, so let's do the next problem. Now this one, we're going to do a quadratic regression. So let's see what a quadratic regression would look like. So I'm going to clear my table. And if you want, you can honestly just delete all these boxes and start from scratch. That's what I'm going to do. And I'm going to enter a brand new table. I'm going to enter my table, -2, and then -2, and then I have -1, then 0, 1, and then 2. Next side, I have 12, 6, 4, 6, and 12. So let's look at this quadratic. So you notice how for quadratics, it's going to decrease and then increase, but sometimes it may be upside down. So for quadratic, it's either going to be an up-facing parabola or a down-facing parabola. So let's find our equation. So for quadratic, our equation model is y equals ax squared plus bx plus c. So I'm going to put y equals, y1 tilde, shift tilde, ax1. And to the power of, we're going to hold shift and press 6 to the power of 2. And then plus bx plus c. So then we should scroll to the bottom to see, I forgot the 1 after x. Here we go. All right, so now let's scroll. Make sure you put the 1s. And make sure after this 2 at the top that you press the arrow to go to the side. So when you put your plus sign, it doesn't end up there. So my a value is 2. So I'm going to write a is equal to 2. That's an ugly 2. B is equal to 0. And C is equal to 4. So when I write my equation, I should have 2x squared. And I'm writing with my finger. That's why it looks crazy. 2x squared plus 0x plus 4. All right, so now let's make a prediction. So step 3, we're going to make a prediction. So let me scroll down over here. And remember, we got to put our equation in. So we have f of x. And I know that looks messy, you guys. I'm going to rewrite it. F of x is equal to 2x squared. So 2x1, just x. And then shift 6 to put the squared. And make sure you put that right arrow plus 0x plus 4. Oops. Plus 0x and then plus 4. All right, so as you can see, our graph goes through all of our data points. Awesome. And now I want to know, what is my prediction? What is f of -5? So if I type in f parentheses and -5, oops, I get 54. So this should be equal to 54. All right, so let's do the last one. Let's do the last one real quickly. So first, remember, step 1 is enter our data points. So we know exponential, if you look at your parent function graphs, exponential, they don't equal to 0. So we have to either go up like this, either it's going to go up like that, or we can have different, it can look different ways. So let me zoom out so you can see the different ways that we can have an exponential graph. So we can, our graph can look like that. So you see how it kind of looks like a quadratic, but the quadratic, it doesn't go up on the other side. So you can, sometimes people get exponential and quadratic mixed up. Make sure you are paying attention to that graph. So let's enter our data points. So let me go back to Desmos, and I'm going to start a brand new table. All right, so we're going to enter our table. I have -11, -10, oops, -9, -8, -7. Man, I was really going in on this table. And then -6, -5. Is that -11, 10, 9, 8, 7, 6, 5. All right. Then we have 20, 48, 10, 24, 5, 12, 256. Oh my gosh, so many numbers. All right, so we have all our numbers in, and so now let's look at our graph. So this is a big graph, so I need to zoom out, and let's make this full screen. All right, so y'all kind of see how the exponential graph, it looks like a straight line, but sometimes we might get that mixed up because we have such a large graph. So this is your hint. This is how you can tell the difference between a exponential graph and a linear graph. Y'all look at the differences. The differences between where x is equal to -11 and x is equal to -10. You notice how they're not decreasing at a constant rate. They're like decreasing at different numbers. That's how you know it's exponential. If it was constant, that means the same difference, then it would be linear. So we know that this is exponential. That is a good hint. All right, so now what we're going to do is I'm going to go back to my notes. And for exponential, I'm going to enter in y1 tilde parentheses b to the power of x. So let's do that. Let's find our equation. So we have y1 tilde parentheses b, b to the power of the whole 6, and then press x1. All right, so we have b is equal to 0.5. So we're going to fill that in our notes. 0.5. So our f of x is going to be 0.5 to the power of x. And let's make our prediction. So we have f of x is equal to 0.5 to the power of x. And we want to know what is f of 0. And f of 0 is equal to 1. So that is how you do data regression. So I just did 3 practice problems with you. I showed you what a, oops, let me zoom out. I showed you what a linear regression looks like here. And a quadratic, we did it on Desmos, but if you don't remember, it can either be, I'm going to draw the graph, it can either be an up-facing parabola, or it can be a down-facing parabola. And for exponential, there can be different types of graphs. So you can have this one, or it can go the other way, or it can be upside down. So if I were to draw those different types of graphs, let me just do that real quick before I end the notes. So let's see, I have different types of exponential graphs. I'm drawing my axes right now so you can kind of see. So we can have it go the way I just showed you. It can go this way, or it can go down. Oops, that was ugly. Let me redo that. Or it can go down the other way. Oops. So our exponential has different types of ways it can look. All right, so I hope this was helpful. What I want you guys to do is try to do these 3 problems. One of them is quadratic, one of them is linear, and one of them is exponential. So when it says regression model, you're going to type linear, quadratic, or exponential. For equation, you're going to give me the equation. And for prediction, you're going to tell me what is the value of y when x is our input value.